Good morning to all of you. As everybody starts to come in and connect, my name is Viviana Medina, and we're super thrilled that you are connecting today to our fourth seminar for our summer seminar series for cacao. And before we officially begin, wanted to make four housekeeping announcements. Number one, the previous seminars are already available in our YouTube page. Also, we have two more seminars left in this summer seminar series. And officially, we have those dates for the National Symposium for Puerto Rico Cacao, which will be on August 30th with a very interesting agenda and some truly wonderful speakers as well. And to remind you that we do have the interpretation service available as well. And you can see that in the bottom part in the globe icon. You click on that globe icon, click interpretation, and you can select the channel for the language that you want to listen in. With this, I leave you and thank you once again for connecting today. And I'll leave you now with Dr. Orozco. Viviana, good morning, and thanks to all of you, and welcome to all of the audience that is connecting to this new episode of the Summer Seminar Series, which is being organized by the Caribbean Climate Hub in alliance with CATIE, and in this occasion in alliance with the Tropical Crop Institute from Peru. And it is a great honor once again to be bringing this webinar to you and to share these knowledge regarding to cocoa. And if you remember, this is, I believe, the sixth webinar that we have put together. Oh, sorry, fourth. Thank you, Viviana, for correcting me. And what we have been speaking as being genetics, we have also spoken about quality. We're also working on cadmium. That's going to be the topic we're going to be speaking, which is based on some new regulations that some countries have been implemented, has had some impact on the commercialization or the selling of the beans. So what we need to do is we're going to be talking about the different facets of the grow of the cacao crop, especially in Puerto Rico, the Dominican Republic, and all the others from all the other countries that are joining us, so that we can have that broader vision and broader strategy of how we have to work through this whole issue of the growing and selling of cocoa. We have with us Dr. Cesar Arevalo. He is part of ICT in San Martin, Peru, of the tropical crop. He's also doing his PhD in Brazil. He has a lot of experience working with cocoa in nurseries, in genetic improvements, comprehensive management of pests, fertility, and has written several scientific journals and articles regarding cocoa and the improvement of fertility in experimental studies. ICT, they do knowledge transfer, technology transfer in Peru, as well as research. And what he's going to be talking to us is the mitigation of cadmium in cocoa and going through several measures that can be implemented from the nursery to the farm. Cesar, I believe, is currently in Tanapoto, in San Martin, in Peru, and we thank him very much for his for joining us today. He will have about 35 minutes for his presentation, and after that, we will have a Q&A session. After that, we will have about 5 more minutes in which we will be opening the forum so that a couple of students from Puerto Rico can share with us about the research studies going to be carried out in Puerto Rico around cadmium, so that we can be more aware of what is being done in Puerto Rico regarding this topic. So once again, thank you, Cesar, for your support, and Viviana and all of the organizers of the Summer Seminar Series for Cocoa. Let's go ahead and start. Thank you very much, Luis, for that wonderful introduction. And today we will speak a little bit about cadmium in cocoa. And I've been fortunate enough to work on this topic ever since maybe 2016, when back then we really weren't sure about what the impacts were going to be about these new regulations that came out regarding cadmium in terms of the selling and the of cocoa. And we also weren't too sure about what was the distribution of this element and what could we do regarding it to mitigate it. So what we're going to do today is I have the information here. It's a lot of information and we don't have that much time. So we'll go through the highlights of this issue of cadmium mitigation. And this has now become a very relevant and important topic in the past few years, along with others as well. So where did all of this issue come about? Well, this started with law number 488, and it's very famous, very well known, because what it did is that it established establish some cadmium limits for chocolate. But since we knew that the principal ingredient in chocolate is cocoa, there was a lot of inferences and a lot of hypotheses about how could the cadmium there be impacting chocolate. So we even had the opportunity to participate in some discussions with the industry, and this was taken into consideration, before the law was approved, to have some warranty or guarantee about the quality of the bean, of the cocoa bean. But again, this is for chocolate, not for the cocoa bean, but there was this whole debate that came up. Now, this law or this rule, which was published in 2014, but again, 5 years to know about a new element and how to mitigate it is not enough time, especially when we talk about a perennial crop like cocoa. To have a productive cycle, you're talking about a year for it to be harvested. So it doesn't matter how efficient you are, you need a lot of time to be able to see some results. This is why in a lot of studies, we try to see at the nursery level, which is easier to be able to test some things. And we could also have faster results. So where do these contaminants come from when we talk about heavy metals, cadmium heavy metals, for example? Now, they have two main sources. One is natural sources, and the other one is anthropogenics or induced. Within these natural sources, we have the geology, like the type of rock that we have in the area that's going to impact a lot the kind of soil that we have in our farms. And of course, the type of absorption rate that the plant will have. If we have some types of rocks, they have high concentration of heavy metals. And in a way, if the soil hasn't gone through an intensive process, it could generate high concentrations of cadmium that can impact the absorption by the plant. Now, in the case of the anthropogenic sources, the most direct ones are fertilizers, or sometimes some organic soil amendments. If they don't have the right quality, could also have high level of cadmium. So there's several studies that have come out to see what are the main sources for cadmium. There's a very interesting one by Thomas, which was published last year, and they work with biodiversity, and they did a mapping, and they did a forecast or some prediction, using some AI techniques that is sometimes able to give us a better prediction or forecast, and that for soil, let me see if I can change, if I can point it out here. They saw that the main variable that could explain higher concentration of cadmium was geology. Then we see here rain season, that's another one, pH, as well as percentage of sand, as well as other components, but the main one being geology. Graham Litch also published another study in 2018, where we see the other components that could have an impact in the amount of cadmium in the soil. And they saw in this case that clay and the geology, as well as the organic matter, were important variables to be able to determine the amount of cadmium in the soil. Now, if we talk about cocoa in beans, we also have different other researches. For example, the Thomas study grabbed all of the possible variables and looked at them. But when we talk about the beans, the main factor is going to be the amount of cadmium in the soil. That's going to influence the absorption. You know, the ones that have less amount of cadmium will have less absorption of this element. Following from there, geology and type of vegetation, longitude, and rain season. We see here this other one that shows us that the amount of cadmium in the bean is going to depend a lot on pH, geology, as well as how much soil cadmium is present. And we see here already some lights, shedding some lights about the amount of metals in the soil. In the case of the beans, we're talking about cadmium in the soil directly, as well as geology. Here, Arguello in 2020 published another article where he shows that organic matter is also important in determining the absorption. And another work that we were able to do earlier, we saw that zinc and iron also have a good relationship with the amount of cadmium absorbed by the beans. So we see here some clues about what may impact cadmium absorption. So let's talk now about the management of cadmium and how we can mitigate it and the mitigation measures, both for a nursery as well as in the field. Now, and they're very similar. What's going to vary a little bit are the dosage of implementation. So for us to deal with contaminants, we have to start with the diagnosis. From that diagnosis, we have to then evaluate what things we need to do and be able to implement some corrective actions and then see if those corrective actions have made a change. And then we continue on this cycle so that we can reduce this element in the greatest degree possible. So what I will do now is I will show you some techniques that can be implemented to reduce the presence of this element in cocoa. So cadmium management is going to depend on 4 key factors. 1, the type of soil, you know, what nature has given us. Then we have the weather, and we have topography. And these 3 components, this is our site index. This is, you know, tied to the natural productive capability of a soil. The one area in which we can truly modify is on the farm practices or agricultural practices so that we can improve the presence of this element. The other ones are very hard to manage because it's what's already present there. But agricultural practices can help us to reduce to the most degree possible the presence of cadmium. So let's talk now about the agricultural practices for the management of the soil. And in summary, these are the ones. Number 1 is the use of organic and inorganic amendments. The other one is to use the adequate fertilizers because we have to agree that if we're working with cadmium, we can't forget the nutrition of the plant. The plant has to be very well fed so that we have at least probability possible of cadmium absorption, and that we can also have a high productivity plant. And this is important because now we have high crop value, historical high values for cocoa. So we definitely have to take advantage of that. Then the use of nanoparticles, something that we're working on right now, and the use of microorganisms. In terms of the microorganisms, we're working both in the nutrition through nitrogen, and we're also working, with cadmium at the microorganism level. But I always like to emphasize on the diagnostic stage. There is nothing more important to be able to do a diagnostic of the area, whether it's soil analysis, leaf analysis, and bean analysis. So we need to be able to implement things, but they have to be based on the diagnostic, because if we don't have the problem, we could maybe try to prevent it, but maybe focusing more on nutrition, which is the most important part. But for us to be able to do a diagnostic, we can use these three types of analysis. But the one that is the most accurate is going to be the bean analysis. And the bean analysis is what's going to tell us that in effect, at the bean level, if we have that problem or not, cadmium problem. Because often when we do soil analysis, cadmium might come out high, but when we analyze the beans, it comes out at a normal level without any problem. So I recommend that if we want to do a diagnostic that would definitely tell us if we have a problem or not, is to do the bean analysis. And of course, this will be a better reflection of all of the post-harvest or pre-harvest efforts that are being done. Now, to do soil management, we have to know our soil. Depending on our soil, we're going to be able to manage it better. If we don't know if our soil is too acidic, or if it has a good amount of magnesium or calcium, or if it has a high acidity problem, we won't be able to fix it. So mitigation for cadmium is always going to need to go hand in hand with nutrition. We always have to mind the nutrition, because if we have an element that is already very high, and let's say that we have heard that the element has an impact on the mitigation of that element, if we apply it to the soil, it's not going to help because the plant has a high availability. So we have to keep track of the nutrition with the mitigation to make sure that they are in tandem, because otherwise the things that we're going to implement in the soil won't have a lot of results because there won't be enough uptake. So I always like to show this table here of how to interpret the soil analysis to know what is the amount of nutrients in the soil and what is the probability of increase in production based on that. So based on the levels that I have in the soil, the answer, as it increases, it will be lower. And because of this, the same thing is going to happen if, let's say, we take into consideration the implement of a soil amendment. We talk a lot about zinc, for example, that zinc competes with cadmium. But if we have a high availability of cadmium in the soil, the most likely is that that amendment is not going to do much for us, different from if there was low availability. So there is a relationship between these two concepts of fertilizing and mitigation. So one of the benefits of the organic amendments, and this is something that we have seen in our field experience, and it's probably the best option that we have, and also the most economical one for a cocoa producer, is that in addition to the benefits of reducing the absorption of the element, cadmium in particular case, is going to increase the growth of the plants. It will improve soil structure, is going to balance the pH of the soil through time. And it's also going to increase the ability of that soil to retain water. Here in San Martin, we're going through climate change where the drought is more severe with time. So the use of organic amendments is very useful to be able to reduce the impact of these climate change effects. Another one that is important and something that contributes a lot, and not just with the mitigation of cadmium, but also with the reduction of disease and any pest, is organic matter. And organic matter will always help with the increase of the microbial biodiversity. You know, not only more diversity, but more quantity of it. So this will help the plant to better handle stress, including heavy metal. Now, I found this in a peer review study that talks about all of the processes that the organic amendments, it I got confused. It says inorganic, but it's supposed to say organic. So we see a modification of the rhizosphere, and this has a lot to do with the microbial activity. We also hear nutrient availability. And one of the key mechanisms in how heavy metal absorption reduction is through the absorption and the complexation of cadmium, which what makes it is that it means that the plant won't absorb it. So then it becomes unavailable for the plant. There are other mechanisms like reduction. And this is, for example, important for chromium and arsenic, in which these go from a toxic state to a non-toxic state. And the other one is, co-precipitation of some molecules. Now, there's other organic amendments that can be implemented as biochar, and biochar, if it's available, it is an excellent organic amendment. And this can be used for the reduction and to improve the quality of the soil that we have. So this is from Idion, and we see here how biochar reduces the available cadmium through time. So the biochar has a strong residual effect, and we can validate this if we take into consideration when we look at the absorption of cadmium in the leaves. So this is the control where there was no biochar application, and we see here the biochar application. So we see that even 6 months after the application, there is a significant difference in cadmium absorption. So the use of organic amendments will help in the reduction of cadmium absorption by the plant. In many cases, we're going to see the total amount perhaps increase, but the amount of absorption will be reduced significantly, as we saw there. Now, other organic amendments like compost can be used to reduce absorption of cadmium. This is a small study. This was guano compost, and there was reduction of the absorption. This is the control, where there was no application of the compost. And we have here a significant reduction of the absorption of cadmium when the compost was used. This is another article that we're in the process of publishing. Hopefully this year it will be published, where we have seen different applications. We have tried guano, we have done cacao shell compost. We compost it and we apply it to the field. And this is the control where there's been no amendment application. And we see here poultry manure. And we have seen that in all of the 3 cases where we have used organic amendments to the soil, we have seen a reduction of cadmium absorption. The cacao tree absorb much less cadmium than the control trees. So it is interesting to see that any organic amendment will be useful to reduce and mitigate cadmium. So when we start working, let's say in the nursery, or when we're fertilizing, always use organic amendments to be able to reduce cadmium or any other heavy metal that could be harmful. Not only that, we're going to be helping with a better nutrition because organic amendments always have a little bit of everything, right? Synthetic fertilizers don't have micronutrients or sulfur, whereas organic uh, amendments do. So not only are we going to reduce the heavy metal element, but we're also going to be providing a better nutrition for the trees. Now let's talk about application of lime and cadmium and all of the other heavy metals. They have a higher availability when they're in high pH. I mean, sorry, when they're in acid pHs. So the best thing is to increase pH to be able to reduce the mobility and that the plant absorbs less cadmium. So we see here Digion's study where we see that depending on the application, in this case of lime, we see a lower amount of available cadmium. So it reduces cadmium's mobility. We see the control one here, the green one. What we saw in the same study is that this reduction is temporary and that after a while it increases again. But this temporary reduction could have a significant positive impact in the absorption of cadmium at the bean level and at the plant level. Because, for example, if we schedule our agricultural activities, you know, in a time period in the formation of the bean that is very early on, let's say if we apply lime at the month when the fruit is starting to grow, and since it takes about 6 months for it to fully develop, we will be in this range where we'll be reducing significantly the absorption of cadmium if we apply lime at the right moment by using lime as a way to control cadmium absorption. We have also tried some sources, and we see that calcium hydroxide helps more than dolomite to reduce cadmium, which it is a good amendment. Dolomite, you know, has magnesium and calcium versus calcium hydroxide that only has calcium. So even though dolomite gives a better nutrition base since it has magnesium, but it's not as effective in reducing cadmium as calcium hydroxide. So we might be able to perhaps do a mix of calcium hydroxide depending on the availability of the material, you know, and we mix it with dolomite so that, you know, we can still have that magnesium added to it. In the same article that we haven't published yet, we looked at other fertilizers, and we see have here our control, and we have the different fertilizers. And we have been surprised here because any fertilizer, independently on how it's mixed, is going to increase the cadmium that can be absorbed by the plant. So for us, it was surprising, for example, because logistically speaking, you know, to buy a synthetic fertilizer much more convenient to do for a farmer or a producer. So if we have a serious problem of cadmium, we should not be using synthetic fertilizers a lot because that will increase the amount of cadmium. Especially this combination of this DAP. If we have to apply this type of fertilizers, you know, to use, you know, TSP, the triple phosphate, since it has calcium, that calcium tends to reduce the absorption of cadmium in comparison to other elements. as well as KSO4, that sometimes we believe that it has an acidic reaction, but it has a neutral reaction. For it to become acidic, it would have to have elemental sulfur added to it. In the case of the sulfate, it will have a neutral reaction. And I always like to clarify this because a little bit of that confusion because of the presence of sulfur. And then moving forward, we have been working with nanoparticles in this past few years, and we started to work with nickel. And when we started to work with nickel, we were surprised that our control, which is basically some trees that were not applied with nanoparticles, we saw a very important response when nanoparticles were applied to them. In this case, what we applied was zeolite. When we applied zeolite, there was a significant reduction of nickel. And this, made us happy. And we tried that with cadmium. But unfortunately, with cadmium, we didn't have the same dramatic reduction as we saw with nickel. We had different characteristics. This is an article that will be published soon. And we didn't have the same characteristics that we saw in nickel. This means that depending on the nanoparticle and the element that we're trying, this can vary. But we see here a ray of hope with ICS, with that clone, because with a higher dose, we've been able to see a significant reduction of the cadmium concentration. And the use of nano particles is in vogue because when we talk about fertilization, these are much more efficient fertilizers. We can definitely reduce the amount of the dose that is used, and it also helps to reduce stress. And not only that, that we could have a reduction of cadmium absorption by using it. So again, it's something that is still being worked little by little, but the idea moving forward is to be able to try to maybe patent it if it's successful. Now, the interesting thing is that these are very small doses that are used. So it could be economically attractive. It's not even a gram that is used of this nanoparticle. And as you can see in this particular case, it is a very significant reduction. But again, we're still testing this with different nanoparticles. We have seen the use of microorganisms, and in this specific case, we have different cadmium absorptions, in this particular case here, and different doses of contamination. So here we see that depending on the type of microorganisms, we will have a significant decrease of the absorbable cadmium concentration. When I was doing my master's degree, I worked a lot with mycorrhizas, but I was working with lead and nickel, on contaminated soils. And we saw very interesting reductions of those levels independently of the type of microorganism that we used. And that we used two different types of them, but there was one that was a little bit more efficient than the other. But the reductions, I think the least that we saw reduction was like 50%, 40%. So if we see here, we're talking about very significant magnitudes.
Another microorganism that's very interesting for us, for example, we have the control. For example, in this case, we're having a cadmium reduction, and it could be done with different species of Circoderma that has different percentages of cadmium. So this is more efficient and more compact, and it could be reduced at a greater proportion, cadmium that is. So this is a very interesting work where with this microorganism, and I don't know if it's available for you, but we use it quite a bit in Peru to research cadmium. It's available in the market. Mycorrhizas also are available in certain countries. And also for the use, we have to apply it when we transplant. We add some grams of mycorrhiza and to the plant so that it comes into contact with the roots and we can colonize it properly. Now, let's work about some practices that are related to the plants. And we will mention some important aspects that have to be taken into account, such as genotypes. First of all, we need to select the adequate genetic material. And we did a small research published in 2021, and we tried some 60 clones, different clones, national and international, national in Peru, and we saw the absorption of them. There's one that absorbs a lot. This is TT40, TCH. And what we want to find is patterns that have less absorption. For example, CCN, it had little absorption, or IMC 67. And we did some work with clones that propagated by seeds, which were used in a parcel, in a plot of land, which is what the farmers use here. And even though there was variability, we had a lesser absorption of the element. There was also an interaction of the pattern, which what was grafted. And sometimes it was clearer than in other cases. For example, here we tried with different doses and saw different interactions. For example, here you can see the level of absorption that is greater or lower for some. So if you take into account the one that was more polluted or contaminated, you can see the interaction of CCN with BN34, which was more, and pH16 clone with the same clone, pH16. So there is a, a pattern of the graft and the seedling that we have to take into account. And we have to see the different levels. For example, sometimes it absorbs more, as you can see in the chart. And this allows us to identify it as it's super productive. And for example, the CNN 50 or 1 and used with an IMC 67, which is lower absorption. So this provides a genetic barrier that's going to condition the absorption. Perhaps our results were a bit high, but the probabilities are lower for us to use varieties that have higher a higher function. For example, T400, pH 990, and BN34 has a higher absorption to what we have seen. So this has to be taken into account. Here we have another work that was published about grafting and rootstocks, and it's different. For example, IMC 67 was a bit higher in some cases, as compared to those that were not grafted. And then we have the plant nutrition. In general terms, what we should always have is good plant nutrition, and this can be attained by doing leaf analysis. We have two ways to act in this case. One, we have the interaction of the change with the nutrients. And two, there's a dilution due to a larger growth. In the case of plant nutrition, we have observed some interesting in relations. For example, cadmium is related to manganese, which is also related to acidity, which provides more availability. But we have not observed much relation with zinc, which is interesting. Also, there's relations with phosphorus and iron. Another important element that I did not add is calcium. The more calcium that we apply, or the more calcium that the plant has as nourishment, the higher the levels of the liming. And also, in the more alkaline, in many cases, there's a deficiency of some elements such as iron or other micronutrients, which could create a larger nutrition of that element for the plant. Now, in conclusion, one, we should use the adequate amendments to reduce cadmium absorption. Above all, organic amendments that could be combined, perhaps with inoculation of microorganisms that reduce absorption. Two, always prefer the use of organic fertilizer or a mix, perhaps 25 fertilized synthetic and the rest organic, or completely organic. And always try to use pure genotypes to have a lower cadmium absorption, and also use genotypes that have lower cadmium absorption to have higher concentrations in the future. And this concludes my presentation. I know that there's so much information, but perhaps I could have given you a workshop for each element, but thanks for your attention. Thanks, Cesar, for your presentation. It was very interesting indeed about the research that has been done with cadmium and the different stages of the crop, from the greenhouse, from the fertility, from the genotypes of cadmium, and also the pattern, or actually the seedling and the graft. That's another interesting phase. The sixth webinar will talk about the seedlings and their effect with the drought. We will be talking about the rootstock, that is. Now, we are going to move on to a Q&A session, and the research in the ICT about cadmium is ongoing. They have a very important genetic collection for cocoa at the ICP, and they have all the material to continue with this research, which will later on make technical recommendations for the Peruvian cacao sector and the neighboring countries. Marcos Obando asked a question in the chat. He wants more details about the doses of biocarbon application in the treatments that you presented and the frequency of the application. Yes, we held a small experiment to try an experiment with the dosage, and I forgot to put it. And we found that the most adequate doses was 1.5 tons for reduction per hectare. So we still have to validate this facts because we tried it in planters, in pots. And what we wanted to do was to try to see the effect on cadmium absorption. But not only did we work with biochar, we tried with biochar and with a cacao husk. And it's interesting because a cacao husk, it's already there. You don't need to buy anything. And this is something that we were able to use with the poultry rootstock and in the poultry manure, that is, and in the biochar, we use about a ton, more or less. Yadira Vasquez has two questions. I'm going to go to the second question. She asks, what are the effects of cadmium in the human body? And have there been any tests in Puerto Rico soil? Yanira, when I worked at the MUCA project, we mapped the in the cocoa bean contact in all of Central America. Also, there's research in Dominican Republic, and all of the producers in South America do as well. In the Caribbean, we had studies in Haiti, Trinidad and Tobago, Jamaica. I am not sure whether there's something for Puerto Rico, but in the cadmium mapping, and we have all of the results have been published and are open to the public. We focus on the cadmium levels in the beans. If they were over the limits of the regulations, then the diagnosis was completed with analyses of soils, of fertilizers to see what the source of cadmium was. I am not sure that this is existing in Puerto Rico. I hope that some research group or university will do it at a given time because the buyers will need that data. And Viviana could probably answer you further. And then Cesar will talk about cadmium in the human body. Hi, Yadira. I have a circular letter that was sent by the University of Puerto Rico, and they state that they are currently doing a research called denomination and determination and identification of heavy metals in the Puerto Rico soil. And we invited some students to talk about this research today and to open the door to farmers that want to be part of this study. We want to invite them as well as the students. I don't know why the students are not in the line, but I can share with you this circular letter where we are requesting farmers to participate in the study. So anybody who's interested can write directly to them to see how they can participate and learn more about the study of heavy metals in Puerto Rico. Thanks, Viviana. Cesar, do you have a comment about cadmium effects in the human body? Well, it affects different areas. First, the endocrine system and also the brain, as as well as stomach irritation and also the nervous system, if I'm not mistaken. This basically happens when there are very high levels of exposition for a long time. But usually the main way that it comes into our body is through food stuff that has high concentrations. But there's other products that have that problem and we don't even know about it. For example, avocado, sometimes we have found out that there's also high concentration in grapes. And these are things that we eat every day, even more than chocolate. And that's important to say. For those who were listening in Spanish and don't know what palta is, we call it aguacate in Spanish, avocado, just in case you were wondering what palta is. Yes, I have a question. First of all, I want to congratulate you on behalf of Oscar Brent from Costa Rica, from FIA, who thanks you for sharing your research. Now, I have a question. Cesar, what have been the effects of high concentrations of cadmium in beans and the marketing of Peru. What are the producers experiencing or the co-ops when they are selling their cocoa beans in the local market or internationally? Honestly, I don't know much about that because I focus more on research. But what I have observed is that historically, before this regulation came into effect, people were afraid. They were saying, oh my gosh, we don't have results. We don't know what to do. And this was around 2019. So, what was positive is that the market was not very affected at that time. There are, however, some requirements that need to be met, but there was still a lot of demand. So their market was not affected. And this is as much as I know. Now there's different regulations, standards. There's one about deforestation, and this is what's really concerning the producers. Now, in terms of effects in the plant, we have seen that cacao can withstand quite a bit of cadmium levels. The first experiments we did with planters to see what levels to use, I think there was some mistakes of calculation. The person that prepared it did not understand well what the concentration should have been and prepared very high dosages, which were about 50 ppm on the subsoil or substrate. And the cocoa was affected the growth, but they were not really dying, although the growth was slow. And we're talking about very high concentrations. Now we work with about 3, and you can see certain effects, but not as strong. Now, um, my father has a hypothesis regarding cadmium and the quality. And he claims that cadmium gives the beans its high quality. And that's why some of them that have the highest quality absorb cadmium. But that's a sidebar. It would be very interesting to see how that works out in reality. The experience of Central America in the framework of this project is that we sampled beans from about 600 farms, and the analysis of and results were given back to the producers and co-ops that were participating. There were some buyers from Germany, France, and Spain, which requested and required a lab analysis certificate each time they bought a cacao container, just to have the backing saying that their beans come from areas that have low cadmium contamination. Each analysis cost $35, and some of them wanted analysis each time they had a new bean lot. So the project organizations had to pay for the cost, and it was an other operation. Viviana? Yes, Luis and I were talking about the new research and perhaps what's being done in Puerto Rico. And you mentioned that first we have to observe the amount of cadmium in the beans, see if it's a problem, and then analyze the amounts of cadmium in the soil. And I know that, Luis, you like controversial questions, but I ask, how necessary are this research in emerging markets and countries, and the emphasis of heavy metals on the soils if there's not an issue of cadmium on the beans? And this is what we were talking about yesterday, and perhaps to expand in this research. And the last question about being concentration and understanding the soils. I ask you, how accessible are the cadmium samples in the beans? Where are they done? How can we access them, etc.? Well, personally, I believe that it is always important to do the screening to see where the problem lies. In addition to this, you can work because otherwise you would be investing in something that really makes no sense. But the question is, why work on it? Perhaps there's not so much levels, but I think the answer is prevention. As more the more I work, the more I see that the restrictions are very strong and they are being extrapolated to other limitations. Perhaps the limits to exports will not affect us. What would have happened if somebody, perhaps in 2008 or 2007, wanted to research cadmium? Well, we would have all the information now before the regulations, and we will have a way to tackle this problem. So this will be something that's more general. Luis, do you want to add something? Perhaps just to add on, in the MUCA project, and this was a recommendation of the Cocoa Research Center, which was partner of the project. The recommendation was do the screening of the beans. You have to be able to trace where the beans come from, what farms or co-ops, to focus on the problem if there is a problem. And if we found cadmium levels that were superior what the regulation states, then we would do an analysis of the soils and fertilizers, etc. The countries that we mapped had very localized problems, especially Honduras and Guatemala. We complemented it with the analysis, and then we defined the recommendations of how to reduce cadmium that was on the soil naturally. There's ways to do remediation, but strategically and logistically speaking, we have to think about the budget. We in Central America mapped what labs of soil and water gave analysis services for heavy metals. Also, what methods did they use to detect cadmium levels? And we had the map to say what were the best labs that had more precision work and backed up our analysis better. So, this is something that could be done in Puerto Rico beforehand to see what labs are available, what equipment they have, the models, and the methods that they use that will influence when we read the results, the cadmium levels. So there's some things that we could do in terms of mapping, but it's something that we should reflect upon before in case a potential buyer wants those results. Perhaps the market of chocolate in Puerto Rico is the US, or the customers did not demand any analysis or certificates, so there's no problems. So who knows in the near future what will happen? Okay, I have an announcement. It is 12 in Puerto Rico, 11 in Central America. And I wanted to thank the interpreters that have given us services and have to disconnect and get off the call. In conclusion, I wanted to ask Luis to please provide the MOCA cadmium reports that you have to make them available for our audience if they want to read more about the mapping. And nothing, I just want to thank you all for your presence. Please connect to the next workshops and suggest ideas for the future to see how we can move forward and bring useful information for you all. Thanks, Cesar, for your wonderful presentation. It was so interesting. and well done. Thank you. Thanks to all. And I love to contribute. Thanks and have a good day. In the chat, I included some links for the MOCA bulletins, but I will be sending you, Viviana, some short documents so that you can find out more about cadmium and cacao. Thank you so much, and I want to invite you to the next webinar on July 12th, 9 a.m. Central America time. And I hope, and this would be 11 in Puerto Rico, I hope that we will be talking about molecular markets as a tool to have a genetic tracing system for cacao. It's done by a foundation in Nicaragua. Thank you and goodbye.